Dear students, today we shall discuss the topic called optical microscopy. This topic is in second part of the module 4. In module 4, this is second part. The optical microscope, also referred as light microscope, is a type of microscope that commonly uses visible light and a system of lenses to generate magnified images of small objects. So, this is a field of examining microparticles which are not visible to naked eye. So the components which are not visible for us through naked eye, we will examine or we will see that components or particles with the help of microscope. So microscope help us to see the small particles by the use of visible light and system of lenses. So optical microscope are the oldest design of microscope and were possibly invented in their present compound from in the 17th century. So from the 17th century onwards, the evolution of microscope was started, and many inventions have been taken place in the field of microscopy. And the microscopes which are present at present generation, they are of very high power and high magnified. So microscopy are used in extensively in microelectronics, nanophysics, biotechnology, pharmaceutical research, mineralogy, and microbiology. So my optical microscopy, they are used in these number of fields: in microbiology, mineralogy, pharmaceutical research, biotechnology, nanophysics, microelectronics, and also this is used in criminology also, because in criminology they wanted to find some examine the fingerprints or any hair particles of the suspect, so that they use microscopy in criminology field also. So the working principle is a simple microscope uses lens or set of lenses to enlarge an object through angular magnification alone, giving the viewer an erect enlarged virtual image. So consider a small object which is placed. So we want to examine that small object. So the basic principle is we will keep that small object in a visible region where there is sufficient sunlight. After that we will look that object by using lens. So this may be by single lens or set of lenses. The object will be magnified, and the virtual image of that magnified image will be shown to us through the use of lenses and its magnification property. The use of single convex lens or group of lenses are found in simple magnification devices such as magnifying glass, loops, and eyepieces for telescope and microscopes. So also you might have used some lenses, magnifying lenses when you were in your childhood. So that is the simple example of the microscope. That is, it will magnify the object which is directed on it. So advantages of optical microscopy. So advantages is this is inexpensive to buy and to operate. This is relatively small. It is small. Both living and dead specimens can be viewed. So we can view both living and non-living particles also. We can examine living or dead animals. Little expertise is required in order to set up and use the microscope. So if we are going to use this microscope, we need to have some expertise and we need to have some basic knowledge of using this microscope. The original color of the specimen can be viewed. That is, we can view the original color of the microscope. So it will not show us the virtual image like different colors. It will show the exact image, exact color of the image, but it will show in the enlarged form. Disadvantages of optical microscopy. So the maximum magnification obtained is 1500x. So what is this 1500x? So consider an example. You are looking a small tiny particle of area 1 square. That is, the area of that particle is both length and breadth of that particle is 1 mm and 1 mm. So the area of that particle is 1 mm square. So this microscope, it can magnify up to 1500 x only. That is, if you consider this x as 1, that is the 1 mm square area which you are looking at right now, so it can magnify up to 1500 in times that size. The size of that particle can be magnified up to 1500 times. So this is what the magnification means. So if the area is considered as 1, if we put 1 in place of that x, then we will get 1500 times we can magnify. Next, specimen may be disfigured during preparation to be viewed under the microscope. So also specimen can be disfigured, that is we can enlarge the image, and also we can cut the image also. The resolving power is 1 nanometer for biological specimens. So the resolving power for biological specimens is 1 nanometer. So the different types of optical microscopes are scanning electron microscope, transmission electron microscope, X-ray diffraction, scanning probe microscope, atomic force microscope, and last one is electron probe microanalyzer. So these are the different types of advanced microscopes which are used in this generation. Now we shall see the first one, scanning electron microscope. So it is a powerful magnification tool that utilizes focused beams of electrons to obtain information. Figure shows simplified schematic diagram of a FEM. So you can see in the figure the specimen which we have to see, it is placed on the specimen holder in the bottommost position. The focused beam of electrons is then scanned across the surface in a raster fashion. This scanning is achieved by moving the electron beam across the specimen surface by using deflection or scanning coils. So the specimen is placed on the specimen holder, and on the top you can see there is an electron gun. It generates a set of electrons. So these electrons are directed towards the specimen, and in between there is two condenser lenses and there is one scanning coil. So these condenser lenses, they direct the electrons and it focus on the specimen, and the scanning coil, it will scan the electrons and it will direct on the specimen. So once the electrons hits the specimen, it will again reflect. And you can see there is a detector. It detects the reflected electrons, and the deflector is charged with opposite polarity. So the deflected electrons get attracted towards the detector, and it is continuously collected through the photomultiplier device. The number of secondary electrons produced by the specimen at each scan point are plotted to give two-dimensional image. In principle, any of the signals generated at the specimen surface can be detected. Most electron microscopes have the detectors for the secondary electrons and the backscattered electrons. So microscopes have detector, that is the detector, it will detect the secondary electrons and backscattered electrons. So backscattered electrons or secondary electrons are those electrons which hits the specimen and it will reflect back. A secondary electron detector is biased with positive potential to attract the low energy secondary electrons. Detector for backscattered electrons is not biased, and high energy backscattered electrons strike the unbiased detector. As backscattered electrons come from significant depth within the sample, they do not provide much information about the specimen topology. However, backscattered electrons can provide useful information about the composition of the sample, but materials with higher atomic number produce brighter images. So if the material have higher atomic number, then the electrons give brighter images. So advantages of SEM. Almost all kinds of samples, conducting and non-conducting, can be scanned. So we can scan and view the conducting or non-conducting particles also. Based on surface interaction, non-requirement of electron transparent sample. So based on surface interaction, there is no requirement of electron transparent sample. That is, the sample or specimen may or may not conduct electrons. That is not the fixed criteria. Even the specimen conducts electrons, or even if it doesn't conduct electron, it is fine. We can use this any type of specimens. Imaging at all directions can be done through rotation of sample. That is, we can take the images of specimen from all the directions. So by rotating the sample, on the bottom of the specimen plate there will be rotating plate. So from that plate we can rotate the specimen and we can get the all directional images. So disadvantages: low resolution, usually above few tens of nanometers. So the resolution of the particle which is scanned, it will have usually about tens of nanometers. Usually required surface strain coating with metals for electron conducting. So as I said, there will be a specimen holder. So that specimen holder has to be surface coated. It has to be coated with the metals so that the electrons hitting that surface should reflect back. So thank you guys. In next class we shall discuss the next type of microscopes, that is transmission electron microscopes. Thank you.